Pre-algebra review. So the first thing we learn in our pre-algebra review are using exponents. So if we have 7 times 7 times 7 times 7, we write using exponents. There are 4 7s, and we can rewrite that as 7 to the 4th. 7 is the base, and 4 is the exponent. So let's simplify. 16 minus 2 to the 3rd power. So if it's 2 to the 3rd power, that means 2 times 2 times 2. We had to deal with that exponent first because of the order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. So we have to deal with the exponent first. We change that to multiplication. We have to deal with that first before the subtraction. So we have 16 minus 2 times 2 is 4 times 2 is 8. So 16 minus 8, which gives us 8. Let's simplify our next problem, problem B, and we have parentheses come first. So let's deal with those parentheses. Within the parentheses, we have 5 minus 2 squared. So we have an exponent and we have subtraction. We have to deal with the exponent first. So that gives us 20 minus 2 times 5 minus 2 squared. 2 squared is 2 times 2. So that's 5 minus 4, which is 1. Multiplication comes next. So 2 times 1 is 2. So 20 minus 2, and our answer is 18. So in part 2 of our review, we have the natural numbers. Sometimes you'll see them called the counting numbers. Should be R. The natural numbers are the set of numbers 1, 2, 3, 4, 5. So let's factor 16. How many ways can we factor it? It says there are 5 different factorizations possible. So it could be 1 times 16, could be 2 times 8, could be 4 times 4. It could be 2 times 2 times 2 times 2. That's 16. Are we through? No, we've got one more way possible. It could be 2 times 2 times 4. How about that? So that's our 5 different ways of factoring. So the factors of 16 are, well, 1's a factor because 1 will divide evenly into 16. 2 will divide evenly into 16. 4, 8, and 16. A natural number that has exactly 2 different factors is prime. It's prime. A natural number that has more than 2 different factors is composite. I like to think of it as being composed of more than just the 2 numbers. The factors of 3 are 3 and 1, so 3 is prime. The factors of 16 are 1, 2, 4, 8, and 16. That's more than 2 factors, so 16 is composite. Determine if each of the following natural numbers is prime, composite, or neither. So, the number 5. Think about the factors of 5. Is it prime or is it composite? What about 9? Prime or composite? What about 23? Prime or composite? And what about the number 1? Now, if it's prime, it has exactly 2 different factors. Well, in 23 and in 5, that was 1 in the number. 1 and 5 are the factors of 5. 1 and 23 are the factors of 23. But if you look at the number 1, it has a factor of 1, but nothing else. So 1 is just an odd case. 1 is neither. What is a factorization of a number using only prime numbers? That's called a prime factorization. Prime factorizations are very important. We'll use them to do many things. So the prime factorization of 16, how do we write it as a multiplication problem that only uses prime numbers? Well, if you look at the ways that we factored 16 above, which one uses only prime numbers? 2 times 2 times 2 times 2. What about a prime factorization of 54? Well, I know that 2 will go into it because it's even. So it's 2 times 27. 27 is 3 times 9. 9's not prime. 9 is 3 times 3. So the prime factorization of 54 is 2 times 3 times 3 times 3. The prime factorization method of finding the least common multiple. We want to find the prime factorization of 2 numbers and then identify the prime factors that appear in each factorization. Multiply these prime factors together using each factor the most number of times that it appears in the prime factorizations. So let's look at the prime factorization of 6 and 9. How can we factor 6 into prime numbers? 2 times 3. How can we factor 9 into prime numbers? 3 times 3. So the least common multiple of 6 and 9, we have to pick out each prime number as many as the most. So how many 2's are there? Well, there's just 1, 2, and 6. There's no 2 and 9, but we don't care. All right, we need a 3. I see 3's. There's 1 3 in 6, but there are 2 3's in 9. So we need 2 3's. 2 times 3 is 6, times 3 is 18. So the least common multiple of 6 and 9 is the number 18. It is the smallest number that both 6 and 9 will divide into evenly. And notice that you can pick out both numbers. 6 is 2 times 3. 9 is 3 times 3. So you're able to pick out both numbers within the prime factors of the least common multiple. We only took 3, as many as it occurred the most number of times in either factorization. As many as the most. So let's do a prime factorization of 12. 12 is 2 times 6. 6 is 2 times 3. Those are all prime numbers, so we're through. 25 is 5 times 5. 40 is 2 times 20, and 20 is 2 times 10, and 10 is 2 times 5. So that's our prime factorization of our 3 numbers. Now let's figure out what the least common multiple is. We need a factor of 2. How many 2's do we need? As many as the most. The most I see is 2 times 2 times 2. So we need 3 of them. What else do we need? Well, we need a factor of 3. There's a 3 right here. So we need 1, 3. That's the only one there. We also need a factor of 5. How many 5s? Looks like 2. I see 2 5s there. So let's put in 2 5s. Now what does this give us? Multiply all those numbers together. 2 times 2 times 2 times 3 times 5 times 5. What do you get? Is it 600? So what can you do with least common multiples? Lots of things. One thing is a problem like we have here. A gym that is open every day of the week offers aerobic classes every third day and yoga classes every fourth day. If both classes were offered today, in how many days will the gym again offer both classes on the same day? There are different ways you can do this. One way is to find the least common multiple. You want to know a number that both 3 and 4 will divide evenly into. What is the smallest number they divide evenly into? 4 is 2 times 2. 3 is a prime number, so we just use the 3. And we have 3 times 2 times 2. That's 12. So in 12 days, they will meet on the same day. Part 3 of our review. We'll begin with writing 24 divided by 32 in simplest form. So 24 and 32 are both evenly divisible by what number? They're both divisible by 2, but is there a larger number that you can divide them by? They're both divisible by 8. So let's divide the numerator and the denominator by 8. So when we divide numerator and denominator by 8, we get 3 over 4. So 24 30-seconds is the same thing as 3/4. Let's write 4 1/2 as an improper fraction. I want to look at a drawing of 4 1/2. 4 1/2 can be thought of as 4 whole numbers. That's 4. And then we have a half, so that's 4 1/2. Well, if we want to write it as an improper fraction, we want to change everything to halves. So we need to cut each one of these whole numbers in half. How many pieces do we have? 2, 4, 6, 8, 9. And that's exactly what we want to say. 9 halves. We have 9 pieces and each one is a half in size. So 4 1/2 is the same thing as 9 halves. You may have seen it as 4 times 2 plus 1 over 2. Same thing. You multiply the whole number times the denominator. That tells you how many pieces you're cutting the whole numbers into. 8 pieces, plus the 1 piece that you had in the fraction. So 4 times 2 plus 1 divided by 2 is 9 halves. Write 10/3 as a mixed number. Once again, we can make pictures. We have 10 pieces that are 1/3 in size. Notice that if we put 3 of those pieces together, we get a whole. This is 1/3, 1/3, 1/3. Put them together and you get a whole. So this will be our whole. This will be a whole. This will be a whole. And you have one little piece left over. So our answer is going to be 3 wholes and that one little piece left over. 3 1/3. You can also say 10 divided by 3. It will go into 10 3 times. That gives you 9 with a remainder of 1. And you put your remainder over your divisor. So 3 1/3. However you want to think about it, you want to get 3 1/3 as your answer. What is 3/10 plus 1/10? You have a common denominator, so you just add the numerators. You get 4/10. Numerator and denominator are both divisible by 2. When you divide numerator by 2, you get 2. Divide 10 by 2, and you get 5. So our answer is 2/5. 10 and 5/6 minus 2 and 1/3. We need to be able to manipulate fractions. So we need a common denominator of 6. We need to fix this fraction so that it has 6 in the denominator. That gives us 10 and 5/6 minus 2 and 2/6. It's going to be 8 and 3/6. What is 3/6? That's the same thing as 1/2. So our final answer is 8 and 1/2. What about when you're multiplying fractions? What do? Well, you can cancel any number anywhere in the numerator with any number anywhere in the denominator. 5 goes into 5 one time, goes into 25 5 times, 9 goes into 9 one time, goes into 36 4 times. We're left with 1 times 4 in the numerator, which is 4, divided by 1 times 5, which is 5 in the denominator. So our answer is 4/5. How do we divide fractions? You can think of it as 3/4 divided by 1/2. I don't want that 1/2 in the denominator. I would like to multiply that 1/2 times something that would make it nice. I wish I could multiply it by 2, the reciprocal of 1/2, 2/1. Then the 2's would cancel and I would get 1 in the denominator. But I can't just multiply the denominator by 2/1. I also have to multiply the numerator by 2/1. That gives me, let's cancel 2 into 4 2 times, that gives me 3/2. So we like to think of division of a fraction as multiplication by the reciprocal. Then the 2 goes into the 4, and we get 3/2 as our answer. When you're dividing by a fraction, you flip and multiply. Write 7.29 in words. So it's 7, and we only use the word and where there is a decimal point. 0.29. The 2 is actually 2/10. The 9 is in the hundredths place. So we have 7 and 29 what? 29 hundredths. With that THS on the end. 29 hundredths. 7 and 29 hundredths. Round 11.6548 to the nearest thousandth. So we have 6 is in the tenths place. 5 is in the hundredths place. And 4 is in the thousandths place. 8 is in the 10,000ths place. So how can we round 11.6548 to the nearest thousandth? Well, the number that we're looking at is that 4. That's what we're looking at. So to decide how to round it, we look at the number to its right, which is the number 8. If the number to the right is greater than or equal to 5, we round up. If the number to the right is 4 or less, we round. We keep it the way it is. So our number to the right is the number 8. It's greater than 5. So we round this to 11.655. So to change a percent to an equivalent decimal, we need to move the decimal point 2 places to the left and drop the percent sign. To change a decimal to an equivalent percent, we move the decimal point 2 places to the right and insert the percent sign. To change a fraction to the equivalent percent, we change the fraction to a decimal and change the decimal to a percent. To change a percent to the equivalent fraction, we drop the percent sign from the given percent and place the number over 100, and then we simplify the resulting fraction. So now we have some problems that we need to work. We're changing each percent to a decimal. The way I remember this whole right-left business is I put D and P in alphabetical order. I'm going from a percent to a decimal. So I want to move the decimal 2 places to the left. If I'm going from a decimal to a percent, I want to move the decimal 2 places to the right. So 72%, currently the decimal is to the right of the 2. If I move it 2 places to the left and drop the percent sign, I get 0.72. 4.25, currently the decimal, is between the 4 and the 2. I want to move that decimal 2 places to the left. There's nothing here in this spot, so we'll put a 0. You may write it 0.0425, or some of you will prefer to put a 0 before the decimal, 0.0425. Either one is acceptable. And drop that percent sign. 100%, currently the decimal is to the right of the rightmost 0. We want to move it 2 places to the left. That gives us 1. 100% is the same thing as 1. Let's change each decimal to a percent. Decimal to a percent. So we're going from decimal to percent, move it 2 places to the right. It's currently between the 0 and the 3. Let's move it 2 places to the right. 33, and we have to add our percent sign. 0.33 is the same thing as 33%. 2.5, we need to move the decimal 2 places to the right. There's nothing to the right of the 5, so we need to put a 0, which gives us 250%. 2.5 is 250%. 0.012, move the decimal 2 places to the right, and we have 1.2%. Let's change each fraction to a percent. So we have 1/2. How do we change 1/2 to a percent? Let's change the fraction to a decimal. So 1 divided by 2. 2 won't go into 1, so we add 0.0. 2 goes into 10 5 times. We need to line up our decimal points. There's no remainder, so 1/2 is the same thing as 0.5. So now it's a decimal. We need to change it to a percent. We need to move the decimal place 2 places to the right, stick a 0 in there, and we have 50%. What about 3/4? Do you know what 3/4 is expressed as a decimal? How many times will 4 divide into 3? Well, 4 won't go into 3, so we'll add the 0.0, line up our decimal points. 4 goes into 30 7 times. 4 times 7 is 28. That leaves us with 2. Let's add another 0. 4 goes into 20 5 times. So 3/4 is the same thing as 0.75. Let's express that as a percent. We move the decimal 2 places to the right, add the percent sign, 75%. 6/5, we need to change that to a decimal. So 6 divided by 5, it will go 1 time. Bring down the 1, let's add a 0. Line up our decimals. 5 goes into 10 2 times, so it's 1.2. Move the decimal 2 places to the right. We get 120. Add the percent sign. 120%. So snow weighs 0.1 as much as water. Snow weighs 1/10 as much as water. Express this decimal as a percent. So we take our decimal, we want to make it a percent, so we have to move the decimal place 2 places to the right. That gives us 10, and we add the percent. So it's 10%. Snow weighs 10% as much as water. A university launched a campaign to collect $3 million to build a new dormitory. If $1.36 million has been collected so far, how much money to the nearest $1 million is needed? Well, we have our $3 million. And we've already collected $1.316 million. We need to subtract to find out how much is left. We want to line up our decimals, add some zeros. And now we're going to have to borrow. You can think of that 3 as a 2 and make that a 10. Borrow from the 10, we'll have 9, and we'll have 10. Borrow from the 10, we'll have 9, and we'll have 10. So 10 minus 6 is 4, 9 minus 1 is 8, 9 minus 3 is 6, and 2 minus 1 is 1. So how much do we need? We need 1.684 million. Yesterday, an athlete swam 2/3 of a mile. This morning, she swam 1/2 of that distance. So we want 1/2 of, in mathematics, of means multiply. So 1/2 of 2/3, cancel out the 2's, 1/3 of a mile. She swam 1/3 of a mile this morning. That's all for this section.